Hello, today we're going to be working on solving systems of equations, day 2 notes. These are going to be the special cases. So we're going to go ahead and solve this system of equations that you see there. From yesterday, we're going to go ahead and label them A, B, and C. We're going to go ahead and pick a variable to eliminate. So I'm going to go ahead and eliminate X. So I'm going to pick A and B. I'm going to multiply A by 4 and B by 5. Okay, when I do that, my x's are going to be eliminated. My y's are going to give me negative 34y minus 60z equals negative 120. Then I'm going to wash, rinse, repeat. I'm going to do the same thing all over again, and I'm going to eliminate x once again. For this one, I'm going to choose b and c, which means I need to take b and I multiply by 3, and I need to take c and I need to multiply it by 2, and that would give me 12s for my x's. So here is a case where when I did this again, my x's are going to be eliminated, but so are my y's and my z's. So I'm going to be left with 0 on the left-hand side. And on the right-hand side, I'm going to also be left with 0. So when this happens, we stop and we say, hey, this is our infinitely many solutions. Now, when you had two equations with two variables and you had infinitely many solutions, you knew it was infinite because you would graph the same line twice. So your solutions would actually be the equation of that line. Now, in the three-dimensional, we have three planes intersecting. So bear with my diagram here. I know it's not the best. But so here we have two planes intersecting, and then we're going to throw in a third plane over here. And all of these then are going to be intersecting at this line right here. And so that's going to be infinitely many solutions because every point on that line gives you a solution. But our question is going to be, what are these what are the solutions? We want to actually figure out with a way to represent the solutions. With two dimensions, again, whatever was on the line, you had the equation of the line. We want to write the equation for the line. So our goal is to write an equation, but the question is, we have to write it in 3 dimensions because we have both the x, the y, and the z. So here's what we do. When we get infinitely many solutions, you're going to take one of your equations that you have eliminated a variable for. So we took and we eliminated x, which means we only had y or z. You're going to take that equation and you're going to pick a variable. Now, it doesn't really matter which one, so I'm just going to pick y. Okay? So I'm going to go ahead and solve for y, which means I'm going to go ahead and add 60z over to the other side and divide by negative 34. So I get y equals negative 30 over 17z plus 60 over 17. And so what we want to do is we want to be able to write our answer as a coordinate point. So I'm going to zoom out here. So we're going to write something, comma, something, comma, something. And I know it's supposed to be infinitely many solutions, but we can actually write the equation of this line, but that equation is going to have a variable in it. So right now what we have done is we have solved for y, and we got y equals negative 30z, or negative 30 over 17z plus 60 over 17. So we have y in terms of z. So what we're going to do is whatever it's in terms of, that's just going to be the variable. And so normally it's x comma y comma z. Since y is in terms of z, we write the z over there. And now what we want to do is we want to get x in terms of z. And so we're going to pick any equation, and I'm going to go back to equation A, and I'm going to plug y into A. Okay? So it's going to be 5x plus 4 times this value I got for y, which is negative 30 over 17z, plus 60 over 17, minus 5z equals negative 10. And so now I still have two variables. So what I'm going to do is I'm going to go ahead and I'm going to solve for one of those variables and get it by itself. And the one I need to solve for is the x variable because I'm still missing that in my coordinate points. If I can get x in terms of z, then I'll have a consistent answer here. All of these would be in terms of z, and that would be my equation of my line in 3 dimensions. So I'm going to go ahead and distribute. I get 5x plus negative 120 over 17z plus 240 over 17 minus 5z equals negative 10. So now what I'm going to do is I'm going to move this 240 to the other side. I'm also going to combine my like terms. So I get 5x minus 205 over 17z equals, that would be negative 410 over 17 when I combine my fractions. And so now I'm going to go ahead and get the z to the other side. I get 5x equals 205 over 17z minus 410 over 17. And x is almost by itself. I do need to go ahead and get rid of that 5, and I'm going to show multiplying by 1/5 only because I already have those fractions there, so it's a little bit easier to visualize. So x should equal, if I multiply and reduce, I get 41 over 17z. So if you multiply 205 times 1 and put it over 17 times 5 and you reduce it, that's where that 41 over 17 is coming from. Likewise, this next one, when you multiply and then reduce it, you should get 82 over 17. So this is my x in terms of z. So it's 41 over 17z minus 82 over 17. And so this answer right here represents the three-dimensional line where our infinitely many solutions would come from. Now you might be saying, well, wait a second, we made a choice at the very beginning. Up here when we highlighted in yellow, we said we were solving for y. What would happen if you solved for z? So long story short, you'll still end up with a similar answer. Let's say we had solved for z. We would get negative 17 over 30y plus 2. And so what would happen then is we would write negative 17 over 30y plus 2 in our z spot. Since it's in terms of y, I would leave y alone. And then what we would do is we would plug z in and into either A, B, or C. And we would solve for our missing one, which would be x. So we would do the same process, and through that process, we would end up with negative 41 over 30 times y for our x. And so this also represents that same line, but it represents it in terms of y instead of in terms of z. And so what's going to happen is you might have a different answer than someone else if you got it in terms of z or y or even x, but they all represent the same line. If you were to plug in 1 for z or 1 for y or 2 for z or 2 for y, those would all represent a three-dimensional point on that line. So either answer is totally fine. Let's take a look at another one of these, because I know that was kind of a lot going on. So let's go ahead and identify A, B, and C. I'm going to go ahead and eliminate Y in this one only because it looks kind of nice. So if I take A and B, those two just naturally, the Y's would eliminate. So I would get 4x plus 4z equals 8. I'm going to go ahead and eliminate y once again. I'm going to choose B and C. I would get 7x plus 7z equals 14. So I'm going to use elimination once again. I'm going to multiply by 4. I'm going to multiply by 7. I'll make it a negative 7. So I get another system here where all of these are going to end up canceling out. I get 0 equals 0, which means there are going to be infinitely many solutions. So now the question is, what are those solutions? So we do actually want to answer with a coordinate point in terms of either x or y or z. So I'm going to take my first equation and I'm going to pick one of these variables, it doesn't matter which one, and I'm going to solve for it. So I'm going to solve for x here. So I'm going to move the 4z to the other side and divide by 4. So right now, at this point, I have x in terms of z. So I'm going to leave x as negative z plus 2, and I'm going to leave z as z. And now I'm going to go back and I'm going to figure out y, and I need to have y in terms of z. So how I do that is I take x, and I'm going to pick any equation. I'm going to pick just a because it's the first one, and I'm going to plug x in. It's negative z plus 2. And I'm going to leave y and the 2z and the 7 alone and distribute. I get negative 2z plus 4 plus y plus 2z equals 7. So I need to get y by itself in terms of z. So as I'm getting y by itself, my z's actually cancel out. And my y value is just 3 for this one. And so what that means is no matter where you are along this line in space, your y value would always be 3, and the x and the z are variable depending on where you are on that line. So this would be our final answer in terms of z. If you happen to have solved it a different way, you might have gotten x, comma 3, comma negative x plus 2 if you would have gone a different way and solved for z at the very beginning there. Okay? So for this next one, we're going to go ahead and set it up together, and then you can try taking it and just solving through it at the end if you need more practice. So we have 3 different accounts. We have account A, B, and C. So I'm just going to use A, B's, and C's because it's already defined. $100,000, it represents our total that we're investing. So however much in A and B and C combined, that equals 100,000. I notice I have another total here in interest. So this is going to be 6,300. And so what I'm going to do is I'm going to tie the percentages on with this. So it's 0.04A, 0.08B, and 0.10C. And then we need one more equation here. We invested 30,000 more in account A than C. So we know we're going to be comparing A and C. C has to be increased by 30,000 to get to A. So that's how we would show that 30,000 more in A than C. So this is your systems. If you wanted to take a moment and solve it, feel free. I'll go ahead and jot down the answer. But other than that, please go ahead and try the homework for tonight, and then feel free to email me or come in with questions if you have any. Thanks.